Hello, and welcome to a lesson on slope-intercept form. So when we started this module, we talked about there are three typical forms we see for linear functions. We talked about slope-intercept form, point-slope form, and standard form. And then, we just sort of talked about general concepts having to do with linear functions from there. So today we're going to focus on that slope-intercept form and why it's so special that it gets its own name. Okay, so first of all, which one of the three was the slope-intercept form? It is the one that is y equals mx plus b, where remember it's the x and the y that are making this a linear function, but m and b get replaced with other numbers. So a concrete example of something in slope-intercept form might be something like y equals 3x plus 4 or negative 1/2 x plus 2. All of these technically are examples of slope-intercept form. Okay, so we talked about slope also specifically in a previous topic. We said slope is labeled with the letter m. And we've also talked about intercepts. Now specifically in this one I want to remind you about the y-intercept. Remember, a y-intercept is a point where our graph will cross the y-axis. And if our graph is crossing the y-axis, let's say that it's, I don't know, here, that would be at 0, 4. Or if it was here, it would be 0, 1. Or if it was here, it'd be at 0, negative 1. No matter where it crosses the y-axis, remember the x value has to be 0. So y-intercept is found by making x equal to 0. Now in our slope-intercept form, if we were to make x equal 0, so if I put a 0 right in there for x, then this term goes away and we're left with this number, which is 4. Put a 0 in for x, this whole term goes away and we're left with this number, which is 2. So that number is always going to be our y-intercept. So this we call slope-intercept form because the slope will always be the number that's sitting right in front of x, and the y-intercept is always going to be the constant that is sitting out here after the x. So m is always in front of x, and then the y-intercept, which we're also going to call now b, is the constant in the equation. So we call this slope-intercept form because it shows us, just by looking at it, the slope of our line, and where it crosses the y-axis, it shows us the y-intercept. Okay, so again, m for slope, and then b is for y-intercept. Okay, so these are all examples of, again, linear functions in slope-intercept form. So just by looking at this, I can see that the number in front of x is our slope. And remember, that means the rate of change from one point to the next is 3 over 1. So if I started at any point on the graph, I could go up 3 and right 1 and get to another point. So my slope is 3 here. And then I can see here that my y-intercept is 4. So there would be a point on this graph at 0, 4. That's where it would cross the y-axis. Okay? Same thing here. I could see my slope is a negative 1/2, which means to get from one point to the next, I would go down 1 and right 2 on this graph. And then here, I can see that b is 2, which means this would cross the y-axis at 0, 2. And again, I can see here that my slope would be negative 5. As a fraction, that would be negative 5 over 1. And so to get from any one point to the next on this graph, I would go down 5 and right 1. And then here, I can see my y-intercept is negative 3, which means this would cross the y-axis at 0, negative 3. Okay, now those are pretty clear. I don't know if the next two are as obvious, but technically there's a number that's sitting here in front of x. When we don't see the number, there is an implied 1. So we're going to say that the slope for this line is going to be 1, or as a fraction 1 over 1, which means I'm rising 1 and running 1 to get from one point to the next. And then my y-intercept, if there's nothing out here, that means my graph is going to cross at the origin. So the number for nothing is 0. My y-intercept would be at 0, or at 0, 0, the origin is where that one's going to cross. And so the similar concept on the next one. The number in front of x this time is a negative 1. So if my slope is negative 1, or negative 1 over 1, 1, I would go down 1, right 1 to get from one point to the next. And since there's nothing being added out here, I would say my y-intercept is 0 or the origin. Okay, and then the last one here, again, I don't know if it's as clear, but this time we don't have a number in front of an x, right? This is still a line. It's just, if you recall, this is going to be, think about what's happening here. Remember, when y equals 4, that means no matter what x is, if I put -1 or 0 or 2, whatever I put in there, the y value has to be 4. If we plotted all those points, -1, 4, 0, 4, 2, 4, we're going to end up with this horizontal line. That horizontal line has no slope. Remember, I'm not rising to get from one point to the next. So this is technically no number in front of x. So I could say there's like a 0x here, or if I wanted to, I could say this is the same thing as 0x plus 4. There's no slope here. My slope is 0. That means there's no rise. That means we have a horizontal line. And then my y-intercept is 4. So it would definitely cross the y-axis at 0, 4. Okay, so there's your slope-intercept form. Hopefully it's clear just by looking at that form what information, or at least two pieces of information, that we can gather, which would give us a new strategy for graphing. So we talked about graphing these before, and what we said was if we're in slope-intercept form, we're going to pick a couple of values for x, we're going to plug them in, and we're going to find values for y, and plotting those 2 points or solutions would help us create the graph. Now that's still going to be true. If we were in standard form, we did the same thing. We needed 2 points to graph, but we decided to choose the intercepts. But here, because slope-intercept gives us such useful information, we're going to try this new strategy for graphing. And if you don't like it, you do not have to commit it to memory, because making the table of values or picking 2 x's still works. So graphing from slope-intercept form can be done using the slope and the y-intercept. So what we're going to do is we're going to plot the y-intercept first. We're going to begin on the y-axis, which may be why they call the y-intercept b. It's where the graph begins on the y-axis. And then from that point, we're going to use the slope to rise and run to the next point. Just remember that when the slope is positive, then we go up and we go to the right. And if the slope is negative, that we will go down and then to the right. So we always run to the right because we start left to right. Positive is up and then right, negative is down and then right. And once we've used our slope to get to the next point, we'll have the y-intercept, we'll have the next point, we can connect those 2 points. Okay, so I like this strategy, but you can decide for yourself after we go through a couple of examples, okay? So I can tell by looking at this graph that m equals 1/2 and that b equals 3. So that means I'm going to begin on the y-axis at 3, okay, at 0, 3. And this is just for good notes for you, okay? So that's what I'm going to do first. I'm going to begin on the y-axis at 0, 3. So 0, 3, and make a point there. That's where this graph crosses the y-axis. And then I'm going to use my slope. If m equals 1/2, then I'm going to go up 1 and then right 2 to make my next point. To make another point. Okay, so my slope is 1/2. From there I go up 2, or up 1, right 2. It's rise over run. So from the point that I just plotted at 0, 3, I'm going to go up 1 and then right 1, 2 and make my next point. And now I have 2 points on my graph. And if I wanted to use the slope again, I can count to as many points as I want. So I can go up 1 and right 2 again, up 1 and right 2 again, as many times as I want, to try to connect these points and make a line. So let me connect them now. And I'm going to just, if you come back later and look at it, you're going to be like, wait, how did she move there? So up 2, or up 1, right 2. And now let me connect. And that's pretty darn good. So this is what that line is going to look like. Okay, now it took a little time because I wrote out the directions of what we're doing, but the goal here, the goal with the new strategy is to be able to work faster, to not have to make a table of values. So let's try this again. If my slope is a negative 3/4 and my y-intercept is 1, then I can begin on the y-axis at 1. So I'm going to begin on the y-axis at 1. And then if my slope is negative 3/4, that's telling me to go down 3 and right 4 to make my next point. So from my point at 1, I go down 1, 2, 3, and then I go right 1, 2, 3, 4, and I make a new point. And now I have 2 points to connect and make my line. And I don't know about you, but that's a lot faster than making a table of values, okay? Now if you don't like it, the table of values is still fine. Remember, you can just pick whatever you want for x. So maybe you pick 0 for x, maybe you pick 4 for x, you plug it in, and you get the corresponding y values, and you plot those 2 points. So if you like that method, by all means use it, okay? Otherwise, let's try this again here. This one, I can see my slope is 5, and I'm going to make that a fraction so I can see exactly how to rise and run to get from one point to the next. And I can see my y-intercept is missing, which means it's 0. So I'm going to begin on the y-axis at 0, and then the slope tells me here to go up 5 and right 1 to make my next point. So from the origin, up 1, 2, 3, 4, 5, and then right 1, and I make my next point. And now I can connect those. That's terrible. Connect those to make my line. Okay. Let's try it again. Y equals 6. So this time I have a y-intercept here at 6, and I have 0x. My slope is 0. So if I'm crossing the y-axis at 6, I begin on the y-axis at 6, and I have no slope. Remember, let's make this a fraction. That means don't go up or down. So no movement up or down, just move to the right to make the next point. So I can see here that's going to form a horizontal line. So that is going to be a horizontal line through those 2 points. Okay, so I like this strategy, but it's up to you. You've got many strategies. You can find intercepts, you can make a table where you pick any 2 x's, or if it's in slope-intercept form, use your slope and intercept. Okay, so one more piece I want to talk about here, and that is the relationship between lines that are parallel and lines that are perpendicular. So if 2 lines are parallel, parallel means they never intersect. So think about train tracks, right? You have the rails on the train tracks that are never going to intersect. That's sort of the concept behind parallel lines. And so if you have graphs of 2 linear functions that are parallel, well, that means they're rising and running at the same rate. So think about 2 lines on a graph. If they're parallel, what's happening is their slopes are going to be the same. So their slopes are going to be equal if they're parallel. And so looking at example 11, it says graph a line that is parallel to y equals 2x plus 1 that passes through the point at 0, 3. So first of all, if we're going to be parallel to this line, okay, parallel to y equals 2x plus 1, that means we want the same slope as this line. So parallel to that line means the same slope as that line. Okay, so what is the slope of that line? Well, the slope of that line is 2, so the parallel line will have a parallel slope that is the same. It will also be 2. Now remember, that's 2 over 1. So I know that I'm rising 2 and running 1 to get from one point to the next. Now we want the line to go through a point at 0, 3. So our line has to go through the point at 0, 3. So I'm going to make that point first at 0, 3. And then I'm going to use my slope to go up 2 and right 1 to make my next point. So if I connect these, then I get my linear function. So there it is. And that is parallel to the line y equals 2x plus 1. And just so you can see it, if I was to graph this line y equals 2x plus 1, I would begin on the y-axis at 1, and then I would go up 2 and right 1 to make another point. And if I connected those, let me get rid of that arrow, I'm sorry. If I graphed this, again, I'm going to begin on the y-axis at 1, I'm going to go up 2, right 1 to make a point, and if I connect those, what do I see? A parallel line, okay? It's a little harder to draw than I thought. These are squishy together. Okay, so the blue one is the actual parallel line. The green one is the one that we started with, but you can see that those two lines are parallel, okay? Now, if they're perpendicular, what does that mean? So, parallel, by the way, the symbol for parallel with these little parallel looking lines. Perpendicular, we have this symbol that looks like an upside down T, because that's precisely what we have when we have perpendicular lines. If two lines are perpendicular, that means they intersect at 90-degree angles. They make like a perfect T, like the x and y axis would be examples of perpendicular lines. Okay, they make 90-degree angles, perfect T. Now, if the graphs of two linear functions are perpendicular, what happens is their slopes definitely not going to be the same. One's got to be positive, one's got to be negative, so they have to be opposite signs. And their rates of change should be opposite, so they're going to also be reciprocals. So, let me show you for example. If we have y equals 3x plus 2, and I said to find the parallel and perpendicular slopes. Well, the slope that we're given here is 3. So if I asked you for the slope of the line that's parallel, well, our parallel slope is the same, so that's going to be 3. If I asked you for the perpendicular slope, the slope of a line perpendicular, it's going to be the opposite sign and the reciprocal. So the opposite of positive 3 is negative 3, and the reciprocal of 3, which is 3 over 1, is going to be 1/3. So for the perpendicular slope, we flip it, and we change the sign, okay? And that might be more clear even so on the next one. So in the next one, the slope of the line that we're given is a negative 3 over 4. So the parallel slope, any line that's parallel to it, would be the same slope, negative 3/4. And then if I said what's the perpendicular slope, well, it would be the opposite sign and the reciprocal. So the opposite of negative would be positive, and the reciprocal of 3 over 4 would be 4 over 3. So we flip it and change the sign. Okay? So if we wanted to graph a line that's perpendicular to 2x plus 1, well, the slope that we're given here, right, the given slope is 2, or 2 over 1. So the perpendicular line is going to have a slope that is a negative 1 over 2. And it tells us our line needs to go through this point at 0, 2. So this is what we're going to use to graph here. We're going to begin on the y-axis at 2. And then we're going to go down 1 and right 2 to make another point. So down 1, right 2 takes me there. And if I connect these, let me try that once more. And that looks pretty good. If I connect these, that is the line that is perpendicular to 2x plus 1 passing through that point. Now, just so you can see what perpendicular looks like, again, I'm going to graph this one. That one's on the y-axis at 1, and I would go up 2, right 1 to make a point. And if I connect those, you see exactly what perpendicular means, okay? Perpendicular means they make a perfect T. There's a perfect 90-degree angle forming in there between those two lines, okay? Now that's just kind of scratching the surface of parallel and perpendicular. For the most part, what I need for you to commit to memory is that parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes, and we will do more with those moving forward, okay? But for now, I think you have enough to get going on the practice, and as always, if you need some extra help, then feel free to reach out. All right, guys, take